Okay, we're going to look now at the change of base theorem for logarithms and discover how useful that is for us in making calculations. So the change of base theorem, let's get straight to it. It enables us, as it says on the can, to change the base. So let's say we've got we're looking at a base of b, and we want to take the logarithm of a to base b, but we don't like b. It's not convenient for us. We might want to change it to base c. Well, we can do that, and this is how. We change to base c, and we do a division. So the ratio of a to b, but changing our base to c. That's it. That's how we change the base. So this c can be whatever we want it to be. Now, quite often, to make calculations, we want this base to be 10, because we have, for instance, we have calculators that calculate base 10 logs for us at the press of a button. We also have calculators that will calculate base e calculations for us. So let's have a look at how this might work for us in action. If we were to look at the example, say, of well, it's going to be more like example, evaluate log of 9 to base 2. Well, okay, this is not something I know off the top of my head, because it's 2. I know that it says 2 to the what gives me 9, or 2 cubed is 8, 2 to the 4 is 16. It's going to be somewhere between 3 and 4. I'm not sure what it is. So one way we could find the value of this is to change the base. Now, I know that my calculator will calculate base 10 for me, so when we change the base to base 10, in fact, I don't even need to write 10 there, do I? We've talked about this. If there's nothing there, we assume base 10. So let's get rid of that. Let's just say it's log 9 over, it's a ratio of log this value to log this value. In this case, log 9 to log 2. We'll go back up to the formula. It's log a over log b, where we change that base to whatever we like. So here it's going to be log 9 divided by log 2, and that just goes into the calculator. Log 9 divided by log 2, and we get, I think, to 2 decimal places, 3.17, which is roughly what we thought it would be. So log 9 divided by log 2. So we've changed the base there. We could have changed it to anything we wanted. Let's say we fancy actually changing it to log base e. So that's so log 9 over log 2. Remember, on your calculator, log base e looks like this. Ln is equal to log base e. So that's something just to remember. We can put that in our calculator, and I'd like you to try to do that now on your calculators. Just put in ln 9 divided by ln 2. You'll find, as you did for log 9 divided by log 2, where you used a base of 10, you're going to get 3.17. So that's quite a powerful little result, that one, changing the base. We're in control. We can change it to whatever we like. What we could also do, and I'd like to show you another way of solving this, or finding the value of log 9 to base 2. It's an algebraic method, and let's have a look at it. The algebraic method would be to take log of 9 to base 2 and let it equal to x. Perhaps I'll just write let here. Let log 9 base 2 equal x. Therefore, if we unlog here, log out. Here we write this as an index equation with the log not there. 2 to the power of x equals 9, isn't it? That's how it looks. 2 to the power of x equals 9. We know none of the y's are they, because we still need this x. 2 to the power of what equals 9? Well, that's 3 less than 4. I know it's 3.17. Let's pretend we don't know that. One thing I want you to know is that you can take the log, both sides of an equation, and we're going to do that here, because the plug law allows us to bring this x down. Wow, that's powerful. That's good, because now we can find out what x is by dividing by log 9 by log 2. And have a look at what we got there. Log 9 over log 2. We've got the same thing up here when we changed the base. Wow, it's all coming together here, isn't it? Here we used an algebraic approach, took the log of both sides, used plog, and we've got the same thing. We know that that's 3.17. We're getting that whichever way we turn. So that's excellent. The change of base theorem is going to be very useful for us, and we're going to get some practice on that in class tomorrow, and that'll be on exercise 4O and exercise 4P. And if you had a little time tonight, you could start on those, exercise 4O and exercise 4P. There's no requirement to get started on those, but if you really wanted to, and you were quite excited about this change of base business, you could get started on that. See you tomorrow.